What if I told you that this flashlight doesn't emit white light, but black light? Did you see that? It's not lighting things up, it's creating darkness. However, black-colored light doesn't actually exist. Here's the interesting thing. Most people don't immediately see anything wrong with that idea. They might even be thinking, we have red light, blue light, green light, purple light, and all kinds of other colored light. So why can't light be black too? Sure, you can have red light, blue light, green light, and purple light, but never black. So why should black be the only exception? To understand this, we first need to look at what black means in two different color systems, the RGB color system and the CMY color system. In the RGB color system, which stands for red, green, and blue, we are dealing with light. This is an additive color system used by digital screens like your phone, TV, and computer monitor. In this system, colors are created by adding different wavelengths of light together. Therefore, black represents the complete absence of light. When a screen wants to display black, it simply turns off the pixels, emitting zero light energy. It is like being in a completely dark room with the lights flipped off. On the other hand, the CMY color system, which stands for cyan, magenta, and yellow, deals with physical pigments like ink and paint. This is a subtractive color system used in printing and physical art. Instead of emitting light, pigments absorb it and reflect only certain colors back to our eyes. In theory, if you mix pure cyan, magenta, and yellow together at maximum intensity, they absorb all visible light, reflecting nothing back, which results in black. So when you look around the world in a way that mirrors the RGB system, your eyes are not seeing the objects themselves, but rather the light reflecting off them. What you're really seeing is light bouncing off objects and then entering your eyes. That's how color works. For example, imagine a red apple. The apple itself isn't creating redness. What's actually happening is that white light from the environment hits the apple. The apple absorbs most light, but reflects red light back into your eyes. And your brain interprets that reflected light as the color red. The same thing happens with basically every object around you. A blue shirt reflects blue light. A green leaf reflects green light. A yellow banana reflects mostly yellow light. So color isn't some magical property floating inside objects. It's a result of how materials interact with light. And this is where black becomes special, because black behaves completely differently from other colors. A white object reflects almost all visible light, but black objects do the opposite. They absorb almost all incoming visible light and reflect very little light back toward your eyes, which means your eyes receive very little light from the object, and that's why it appears black. So, when you see black, you are not seeing a special kind of light. You're seeing the absence of reflected light. And that's a really important distinction, because red light is light, blue light is still light, but black is what happens when light is missing. In other words, black is not something being added, but something being taken away. So, if you treat black simply as a color or shade here, the idea of black light becomes a lot more strange, because saying black light is almost like saying bright darkness. Obviously, the concept kind of contradicts itself. But now things get confusing again, because there actually is something people call a black light. You've probably seen them before. They're used in clubs, escape rooms, amusement parks, forensic investigations, and even counterfeit money detectors. They give off that eerie purple glow, and suddenly white clothing starts glowing like it's radioactive. Ultraviolet light is completely real. It's part of the electromagnetic spectrum, just beyond the violet end of visible light, which means you can't see it directly. Visible light is actually just a tiny slice of all possible electromagnetic radiation. Your eyes can only detect wavelengths from roughly 380 to 780 nanometers. Yes, that's it. Infrared exists beyond red. Ultraviolet exists beyond violet. Radio waves exist. X-rays exist. gamma rays exist. They're all electromagnetic waves and light as well. Yes, you heard that right. In a broad physical sense, they're all forms of light. Your eyes simply are not built to detect most of them. So UV lamps are not producing blackness. They are producing photons, the quantum units of light. It just happens to sit outside normal human vision. And since we can't see it, to us it looks like pitch black. Simply put, UV light is called black light, not because the light it emits is black, but because the light it produces is invisible to us, and what we cannot see appears as black. The light is absolutely there. In fact, you can literally observe its existence. Under UV light, neon paint glows, white shoes glow, ripe bananas glow, and even scorpions glow. That happens because certain materials absorb ultraviolet energy and then re-emit part of that energy as visible light. This process is called fluorescence. Now, you might be wondering, if UV light is supposed to be invisible, then why we always see a purple glow? Actually, most UV lamps are not perfectly pure UV sources. They typically leak a small amount of visible light, especially in the violet range. Another important reason is that this leakage serves a practical purpose. Since pure UV light is completely invisible to the human eye, the faint, visible violet glow acts as a crucial safety indicator, letting users know the lamp is turned on and operating. However, manufacturers try to keep this visible light to a minimum, as too much stray violet light can actually mask or drown out the faint fluorescence emitted by objects under the lamp. So in the end, light is something that adds information to the world. It reveals, it illuminates, it allows your eyes to detect reality. But blackness? It's just the lack of that information. You can create invisible light. You can create materials that absorb almost all light, but you can never truly emit darkness. So, this thing? Well, I thought everyone knew that was a special effect. Because black isn't a type of light, it's what we perceive when little or no light reaches our eyes. Light can be red, it can be blue, it can be green, but it can never be black. And that's why a truly black beam of light can never exist. Okay, that's all for this video. If you found this interesting, a like would really help, and feel free to subscribe if you want to see more curious science explained simply. Oh, please hold on. I almost forgot our final curious question. If black-colored light did exist, what do you think people would use it for? Just let me know in the comments.